Hey everybody, welcome back to my channel on trigonometric functions. So, last video, all I did was introduce the 6 trigonometric functions, but I didn't actually do any examples with them. I really just laid them out and told you how they were defined, as in like sine of theta is the opposite side over the hypotenuse side of a triangle, cosine is adjacent over hypotenuse, tangent opposite over adjacent, etc. Right? We had the 3 reciprocal trigonometric functions as well. Now I'm going to do our first example on evaluating trigonometric functions. Let's get started. Okay, so I have the same triangle that I used earlier. This is a 3, 4, 5 triangle, one of the most common right triangles in all of trigonometry. It's one of the Pythagorean triples, right? Meaning there's just no radicals in there. It makes everything easier, right? Because sometimes you might have one of the side lengths be like a square root of 17 or something ugly, but I digress. Anyway, let's evaluate our 6 trigonometric functions. Because we already have our 3 sides, this is not going to be very tough at all, I don't think. Okay, so I can see here that my angle theta is down in the bottom right, so that is the angle in question. That is the center of attention right there, the person who wants everyone to look at him in the room, right? This is the one we're talking about. Not this one, not that one. So, angle theta, I'm looking at the triangle from angle theta's point of view. What is the sine of theta? And by that I mean, what is the ratio of the opposite side to the hypotenuse? Well, the opposite side is 4 and the hypotenuse is 5. That means the sine of theta is 4 divided by 5. 4 over 5. Done with that part, right? All right, next one is the cosine of theta. The cosine of theta is the adjacent side over the hypotenuse, right? So it's the adjacent divided by the hypotenuse. Okay, so in this triangle, it is 3 divided by 5. 3 over 5. Boom. Not boom. All right, and then the tangent, the last regular trigonometric function. Tangent of theta. The opposite divided by the adjacent. So, the opposite divided by the adjacent. 4 divided by 3. 4 divided by 3. Okay. And then we have the 3 reciprocal trigonometric functions. Okay. The other 3. First, we have the cosecant of theta, right? This is the reciprocal of sine, right? I laid them out. These are reciprocals, these are reciprocals, and these are reciprocals, right? So, the cosecant of theta, that is the hypotenuse divided by the opposite. So, from right here, the hypotenuse is 5, and the opposite is 4. So, 5 divided by 4. 5 divided by 4. You may also notice that if I looked at sine and cosecant, 4 over 5 became 5 over 4, right? I literally just flipped it. That's it. Nothing else to it. Secant of theta is the hypotenuse divided by the adjacent. So, the hypotenuse divided by the adjacent. 5 divided by 3. And again, cosine and secant are reciprocals of each other. 3 over 5 became 5 over 3. Very, very nice. Lastly, the cotangent of theta. I don't even need to look at the triangle anymore. I know that tangent and cotangent are reciprocals of each other. 4 over 3 is probably going to become 3 over 4, right? So let's think. Adjacent over opposite. Adjacent 3 divided by opposite 4. Woohoo! Rock and roller coaster right there. All right. And that's going to be all for today. That is evaluating trigonometric functions given a right triangle. Thank you all for watching.